Yeah, you are welcome to a topic in further maths, Binomial Theorem. I want to look at binomial theory or binomial expansion. Now, this diagram we have in here is a typical example of binomial theorem, but in this case, we call this a Pascal triangle, and it has a natural phenomenon in this, and it also have something like this. Now let's move on with the topic. Now your starter activity, you can quickly do it for 5 minutes. Now, a binomial theorem provides a useful method for raising any binomial to a non-negative integral power. Now, binomial, the word binomial simply means when you have two numbers or two letters. And that's what we mean by binomial. Then when you now raise it to a power of n, it is usually difficult to multiply, especially when the power of n is more than 6. So in this topic, we are going to be looking at how to multiply that in a way. But before we continue, you will recall that x plus y raised by 0 will give us 1. We can also quickly recall that any raised by 1 will give itself back. So x plus y raised by 1 will give us x plus y. Now, what do you think this will be? If we now have x plus y raised by 2, that will give us x squared plus 2xy plus y squared. Going back that, if you have x plus y raised by 3 equals x raised by 3 plus 3xy plus 3xy squared plus y cubed. You can see the pattern at which this is moving. Look at this also. X plus y raised by 4 equals x raised by 4 plus 4x raised by 3. You can see the pattern. The pattern such that x started with 2 and is reducing to 1, and y is just starting and is increasing. If you check for x plus y raised by 3 as well, it started with x raised by 3 and it went to x raised by 2, y just started raised by 1, then it moved on like that. So x reducing to 1, y raised by 2, then y raised by 3. If you look at this as well, this started with x raised by 4, the x went to x raised by 3, reducing, while y is starting with 1, x is reducing, y is increasing, x is reducing, y is increasing until there is no more x. So this is a pattern you are going to be looking at. Now look at this as well for 5. You will notice as well that it started with x raised by 5, x raised by 4, y is starting with 1 until we no longer have x, then we have y raised by 5. Note that each term is expanding or is increasing by n plus 1 term. You notice that x plus y raised by 0 equals to 1 has just one term because it has raised by 0. The one that has raised by 1 has 2 terms. That means n plus 1. The one that has x plus 1 raised by 2 has 3 terms. The one that has raised by 3 we have 4 terms. The one that has raised by 4 we have 5 terms. And the one that has x raised by 5 we have 6 terms. And the pattern continues that way. I will be seeing you in the next video where we talk more about binomial theorem.